So the next few videos I make are going to be the solutions to the test that I gave you on Friday, November the 15th. And I would highly encourage you to take pretty detailed notes of these solutions and to attempt to rework them, because the performance on this test was, I'm going to be really nice here and say not good. So let's start with number one. And in question number one, we are tasked with finding the energy emitted and the emission wavelength for a transition in the hydrogen atom from N equals 8 to N equals 6. And so we know that this change in energy is equal to Rydberg's constant times 1 over the final N squared minus 1 over the initial N squared. So delta E is equal to 2.179 times 10 to the minus 18 joules. And this will be 1 over 36 minus 1 over 64. Now my advice on this is that you use the power of your calculator rather than trying to find a common denominator. So I'm actually going to enter this in the calculator. And this is important because so many of you, when I looked at your work, it was fine, but you are still failing to realize the importance of using parentheses and solving this problem one step at a time. So literally, I'm going to type in 1 divided by 36 and hit the enter button. I'm going to subtract from that, parentheses, 1 divided by 64, end parentheses, hit the enter button, times, in parentheses, 2.179 second E to the minus 18, enter. And I get 2.65 times 10 to the minus 20 joules. This answers the first part of question 1A. Now the next part centers around delta E is equal to HC over lambda. Now when I rearrange this equation, I can cross multiply, divide both sides by delta E. Lambda, the wavelength, is equal to HC over delta E, which is 6.63 times 10 to the minus 34 joules times seconds times 3 times 10 to the 8 meters per second divided by 2.65 times 10 to the minus 20 joules. Joules cancel, seconds cancel, and my answer will be given in meters. And when we simplify this, we get an answer of 7.511 times 10 to the minus 6 meters. Several of you did that part properly. Many of you mislabeled the unit. Many people reported joules. You've got to understand the appropriate unit that goes with the question that you're answering. If you give me the right number in the wrong unit, you should expect nothing more than a mercy point or two at most. You're not going to get majority credit, and those mistakes do add up. Now on the table, it asks for the emission wavelength in nanometers, and we know that there are 10 to the 9 nanometers in 1 meter. So I'm essentially multiplying by 1,000, which means I'll move the decimal point 3 places to the right. So in terms of nanometers, this is 7,511 nanometers. Since I specify nanometers in the problem, the answer needs to be reported in nanometers. If you reported it in meters, I essentially deducted a point out of 7. So you got majority credit if you did that. It's important to follow the directions and follow the instructions completely. So now that I've gone through the first one, I think it would be good for you to try the second one. We want to calculate the energy emitted per photon and the emission wavelength for a transition in the hydrogen atom from n equals 7 to n equals 2. You will use the equation delta E, which is equal to hc over lambda, which is also equal to Rydberg's constant times 1 over nf squared minus 1 over n original squared. And the variable that we're solving for, besides the energy, is the emission wavelength. Solve this question, and once you have an answer, seek me out before class, after class, before school, after school, so that you can successfully challenge this on a remake opportunity that I will give you in the near future.